Airtech International Incorporated, providing the latest in resin infusion materials and technology to the industry's leading companies. Today we will be demonstrating the resin infusion processing of a carbon fiber car hood. The first operation in producing our car hood is to apply 2 to 3 layers of mold release. In later processes, additional coats should be applied as required to prevent part sticking. Here we are using Airtech's Release All 50. Next comes the gel coat application, which is applied approximately 1 mm thick. Several layers of cloth are placed against the mold. Subsequent plies are held down using a spray adhesive, such as AirTac 2. The extra cloth is trimmed, leaving a clean part. Another way to tack down cloth is by using an adhesive mesh, such as Airtech's Tack Strip. Here we apply a vacuum bag sealant tape for providing a seal from the vacuum bag to the mold. In this case we are using AT200Y, one of our more economical sealant tapes. After that, we apply a double-sided tape such as Airhold 10 CBS. This allows us to later secure the polyethylene spiral wrap required for a peripheral vacuum manifold. The spiral wrap is then applied to the periphery of the mold just inside the sealant tape. Peel ply is the next material to be applied, in this case directly against the cloth. Here we are using 2 different types, bleed release B in green and stitch ply A, which is white with red tracers. This is done for the purpose of illustrating that a release coated peel ply, in this case bleed release B, is much easier to release than a non-coated peel ply. However, there is a trade-off. A non-coated peel ply will provide a much better surface for secondary bonding. Spray adhesive is used to stabilize the peel ply to prevent the material from shifting. Strips of peel ply are cut to fit around the spiral wrap. This peel ply is used to provide vacuum continuity between the part fabric and the vacuum channel. These are held in place with AirTac 2 spray adhesive. It is important to trim the peel ply so that it does not later interfere with placing the vacuum bag against the sealant tape, which could cause a leak path. Next comes the placement of the resin flow distribution media. Here we are using Airtech's Green Flow 75. This mesh is held down using our spray adhesive and trimmed just inside the spiral tubing. The flow medium provides an efficient method for distribution of resin across the part surface. OF625V resin flow lines are cut to size and placed over the resin distribution media. This product is reusable. Here we are using Flashbreaker 1HT to hold the resin flow lines in position. We are now ready to apply the vacuum bag. Typically, the bag should be 30 to 40% larger than the part surface, depending on the complexity of the shape. Here we are using Airtech's Ipwan KM1300 vacuum bagging film. The vacuum bag is adhered to the sealant tape in strategic locations for proper positioning. The sealant tape paper is pulled away as the film is pressed in contact with the tape. The remaining open portions of the vacuum bag are called pleats. They are filled in with sealant tape using the technique shown, which is only mastered with some practice and know-how. Let's look at that again. Here we insert a polyethylene fitting into the spiral wrap and attach an external polyethylene tube. This is done to provide a vacuum source. The external tube is then placed onto the RB451 vacuum reservoir. This is to provide vacuum and containment for any excess resin that may get into the peripheral vacuum channel. Other solid tubes are attached to the Omega flow lines and then sealed under the vacuum bag. In preparation for the resin infusion, clamps are applied to all resin inlets. Vacuum is then applied. You can see the vacuum draw the bag against the mold. Here, full vacuum has been applied, but let's make sure by doing a leak check. We remove the vacuum source and find that over a period of time, there is no vacuum loss. Vacuum integrity is critical to this process. When we are ready to infuse, we first add catalyst to our resin. The inlet tubes are placed into the bucket and the first clamp is released. Once the resin from the first tube has nearly reached the paths of the second and third lines, the first line is clamped off. Then the second and third clamps are released. Resin lines should be placed so that the part is progressively infused without trapping any dry areas. The resin on one side has reached the outer limits of the part, and so we clamp it off. As resin reaches the last corner of the part, the third line is clamped off and the part is left to completely cure under vacuum. After a complete cure, the vacuum bag materials are removed. AirTech has low temperature and high temperature resin flow lines for different applications. Because the OF625V resin flow lines are reusable, they are ready for another infusion process. Notice that when the peel ply is removed, the release-coated bleed release B on the left peels much easier. The part is removed and the result is a high quality laminate.